Welcome to the deep dive. Today, we're tackling a set of fundamental Python skills, things that really pack a punch in cybersecurity.
Yeah, we're talking about working with strings, how to sort of wrangle lists of data, and then unlocking the power of regular expressions for pattern matching.
Okay, so these sound like core tools.
Exactly.
Yeah.
We've got some great materials showing just how essential these, well, basic Python tools are for anyone aiming to protect digital systems. Think of it like arming yourself with the core techniques for, really digging into the data.
Right. So our mission today is to get a solid handle on these core Python concepts, dealing with text, collections of data.
And then finding specific patterns within all that data. Yeah.
And the crucial part, I guess, is seeing how these skills apply directly to real-world cybersecurity scenarios.
Absolutely. Because in cybersecurity, you're constantly swimming in text, aren't you? Analyzing logs, investigating system events, maybe just managing user accounts.
Yeah.
Python's capabilities with strings and lists really shine here.
Okay, so let's dive into strings first then. I mean, like you said, in cybersecurity, we're surrounded by them. IP addresses, usernames, URLs.
Employee IDs, device identifiers.
Right, exactly. They're all just sequences of characters, fundamentally.
Precisely. String data is kind of the bedrock for information that isn't primarily for, like, calculations. And, yeah, huge amount of security info falls into that bucket.
So you might need to pull out part of an IP address, maybe? Or check if an employee ID looks right.
Exactly. Confirming formats, extracting specific pieces of information, that's where understanding strings is key.
Okay. And Python gives us a really precise way to target individual characters using indices, right?
Indices, yeah. It's like assigning an address to every single character in the string.
So take a device ID like H32 or B17.
Okay.
The H is at index 0, 3 is index 1, and so on, up to 7 at index 6.
Right, standard zero-based indexing.
But here's the cool trick. You can count backward, too. So 7 is also at index -1.
Negative indexing. Yeah, 1 would be made as 2, all the way back to H at -7. That could be handy sometimes.
So how do we use these indices?
Well, you leverage them with bracket notation. That lets you pull out exact characters or even segments of the string. Those are called slices.
Okay, so like device 0 would give me H.
Yep, just H. And if you wanted the first part, like H32, you could use a slice, device 0.3.
Ah, 0.3. So it goes up to but doesn't include index 3.
Exactly. That ending index is exclusive. But this ability to programmatically isolate specific bits of data is just incredibly valuable in security.
I can see that. Imagine you need to grab the first few digits of, I don't know, a whole batch of device IDs to categorize them or something.
Slicing makes that really efficient, yeah.
Okay. Now, Python also has these built-in functions, standalone tools.
Right. Functions that work on strings but aren't, like, part of the string itself.
Like, I've seen that one for
Right.
turning numbers into strings.
Exactly. Super useful. Say you have an employee ID, maybe 19329302, but it's stored as an actual number. You'd use Strio to convert it to the string 19329302, so you can then, search for it in text or maybe slice it if you needed to.
Okay, makes sense. And len, that tells you the length.
Yep. Len gives you the number of characters in the string. In security, this is often crucial for validating data formats.
How so?
Well, maybe all your valid API keys must be exactly 32 characters long. You could use len on a key you receive to quickly check if it even meets that basic requirement before doing more complex checks.
Ah, gotcha. A quick sanity check.
Precisely.
Okay, so we can grab parts with indices and slices, convert numbers with stride, check length with len. What about these methods you mentioned? Actions the string performs on itself.
Right. String methods, things like .upper and
For
long.
changing case. Seems simple.
It seems simple, but think about standardizing data. You might have logs with suspicious activity detected and another log with suspicious activity detected.
Different capitalization.
If you convert everything to, say, lowercase, using lowercase, then suspicious activity detected will always match, regardless of the original case. It makes your analysis much cleaner, more consistent.
So you don't miss things just because of capitalization differences. Good point.
That standardization is really vital. Then there's another really useful method, .index.
Index, what does that do?
It's like asking the string, where's the first place this character or sequence appears? And it tells you the starting index.
Okay, so back to H32 or B17. If I did .index,
It would return 3 because R is at index 3.
what if the character appears more than once? Like in a R45, 46. If I search for R...
Good question. .index only gives you the first instance it finds. So R40 46.indexR would return 0.
Only the first one. Got it. What if it's not there at all? Like h32rb17.index,
Oh,
say.
that's crucial. If the character or substring you're looking for isn't found, .index actually raises an error. It'll stop your script if you don't handle it.
Okay, that's important to remember for automation. So
Yeah.
you can search for substrings too, not just single characters.
Absolutely. You could search for, say, destination in a log line like source.192.168.1.m destination.10.0.0.5rm.
An index destination would give you the starting position of that word.
Exactly. It would return 19 in that case. But again, be careful with shorter overlapping strings. If you search for just S in that same string,
It would find the S in source at index 0 first.
right, which might not be the S you were actually interested in. So understanding its behavior, first occurrence only, error, if not found, is really key.
Okay, so recapping strings, indices, and slicing to grab parts, stusure to osys to convert, len for length, and methods like .upper and .index to standardize and find things seems like a solid toolkit.
It really is.
Now let's shift gears to lists, because, in cybersecurity, we often deal with collections of things, don't we?
All the time, lists of suspicious IP addresses, maybe usernames that triggered alerts,
Yeah.
URLs from a phishing campaign.
Yeah, exactly.
Lists in Python are just incredibly useful for storing these ordered collections. And what's powerful is how you can then easily iterate through them, go through each item or perform actions based on what's in the list.
Like checking if an incoming IP address is on a known block list.
Perfect example. You'd have your block list as a Python list and just check if the incoming IP is in that list.
Okay. And lists have indices too, right? Like strings, starting from 0.
Yep, same zero-based indexing. If you have a list, say, a Larson for Garcia, Tisha, Skillmore.
Okay, a username list.
The Larson is index 0, for Garcia is 1, Tisha is 2, Skillmore is 3.
And bracket notation works the same way. Username list 2 gives me Chesh.
Exactly. And slicing works too.
Yeah.
Username list 0.2 would give you a new list. A Larson for Garcia, remembering that the end index is exclusive.
Right. Up to, but not including, index 2. Now,
Hmm.
you mentioned something about lists being different from strings.
Mutable. Ah, yes. Mutability. This is a key difference. Lists are mutable, which means you can change their contents after they're created. Using bracket notation on the left side of an assignment, you could literally say username list 1 at Birreno.
And that would replace for Garcia in the original list.
Yep. The list itself is modified. Strings are immutable. You can't change a character in a string like that. You'd have to create a whole new string.
So that ability to change lists in place is useful for updating things, like adding a new blocked IP or changing a user status.
Precisely. It makes lists very flexible for dynamic data.
Okay. And like strings, lists also have methods.
They do. Actions the list can perform on itself. For instance, .insert,
To insert something where...
wherever you specify.
Yeah.
Username list.insert to Jaffrey would put Jaffrey at index 2.
And what happens to Shah and Skillmore?
They get shifted one position to the right to make room, so the list grows.
Okay. What about removing things?
For that, you have .remove. You give it the value you want to remove, like username list.remove a Larson.
And it finds a Larson and takes it out.
Exactly. It removes the first occurrence it finds. If a Larson was in the list twice, only the first one would be removed.
First occurrence again, got it. Any other common ones?
.pend is probably one of the most common. It just adds an element to the very end of the list.
So username list.append, btang, just sticks btang on the end.
Yep, super simple. And you see it used all the time inside loops when you're building up a list of results, like collecting all the IP addresses from a log file search.
Right, you loop through the file, find an IP, and append it to your results list.
Exactly. And finally, lists also have an .index method, just like strings.
Does it work the same way? Finds the index of the first occurrence.
Pretty much, yeah.
Mm.
Username list.index, Chisha, would return 2.
Yeah.
Same principle, first occurrence only.
Mm.
And it'll raise an error if the item isn't in the list.
Okay, so even though it's got the same name, it's technically a different method because it works on lists.
Correct. It's the list's version of .index.
All right, so for lists, bracket notation for access and changing things because they're mutable, and methods like .insert, .append, and .index for manipulation. Feels like a good set of tools for managing collections of security data.
Definitely.
Okay, let's move on to the last piece. Regular expressions. These sound powerful, maybe a bit intimidating.
Huh. They could seem that way at first, but rejects. They are incredibly powerful. Think of them as defining a pattern to search for within text.
A pattern, not just a fixed sequence.
Exactly. A flexible, concise search pattern. In cybersecurity, this is just invaluable for finding things like IP addresses in a messy log file, or pulling out all the email addresses from a big report, or maybe recognizing patterns linked to malware in code.
I can see how that would save a lot of manual searching.
Oh, countless hours.
So how do we actually use them in Python?
Okay, first step, you need to import re. That brings in Python's regular expression module, the special toolset.
Port re, got it.
Then, a function you'll use a lot is re.findall.
Findall, okay.
It takes two main things, your regex pattern and the string you want to search in. And what it gives you back is a list of all the bits of the string that matched your pattern.
A list of matches.
Yep, non-overlapping matches. So a simple example. You search for the literal string TS in T snow, T sha B moreno. TS, T snow, T sha B moreno.
You'd get a list with TS.
Exactly. It found both of them.
Okay, that's simple enough, but you said patterns, not just literal strings.
Right. The real magic comes from special symbols you can use in the pattern. For example, W.
\W. What's that?
That matches any word character, basically letters, upper, lowercase, numbers, 0, 9, and the underscore character.
Okay, so if I used W on our device, ID H32 or B17, corrode I pundal,
Okay.
plot each of those characters individually, you'd get a list. H32 RB17.
Ah, because they're all word characters. Are there others like that?
The dot DS is a wild card. It matches any single character except a new line. Anything at all.
Any character. Wow. Okay. Then D specifically matches any digit, 0 through 9.
B for digit.
E matches any white space, character space, tab, new line, etc.
It's for space.
And if you actually want to match a literal dot, since the dot itself is special.
You'd have to escape it.
Exactly. You use to match a literal period.
Okay, so WDDS, those match character types. What else?
You can specify how many times something should occur using quantifiers.
Quantifiers, like?
The plus sign plus A means one or more of the preceding thing. So D plus would match one or more digits together.
So on H32 or B17, read.findall, DA32 or B17 would find.
It would find sequences of digits. It would return 3217.
Ah, because it groups consecutive digits. What about the star 8?
The asterisk means 0 or more occurrences. It's similar to plus A, but it will also match if the thing isn't there at all, which can sometimes lead to empty strings in your results list.
Okay, 0 or more. A bit more flexible. Are there ways to be more specific, like exactly 2 digits?
Yep, curly braces are for that. D2 matches exactly 2 digits.
So if I ran D2 on, say, H32 or B17, K825T as Ermito, C2994.
It would scan through and find all pairs of digits. You'd get 32, 17, 82, 25, 99, 94.
Wow, okay. It finds all of the 2-digit sequences. Can you do ranges, like 1 to 3 digits?
You can. D13 would match sequences of 1, 2, or 3 digits.
For range, got it.
Now, let's try and tie this to a security example. Imagine a log line like, user B Marino logged in from IP 192.168.1.0 at 14.35.
Okay. And we want the IP address.
Right. We know an IPv4 address generally looks like 4 numbers, each between 1 and 3 digits long, separated by dots.
So we could build a pattern, D13 for the numbers, and for the literal dots.
Yeah,
maybe.
D13.
Exactly. That pattern describes an IP address structure. If you use re.findall with that pattern on the log string,
it should pull out just 192.168.1.1 to a size.
You've extracted the specific piece of information you needed using a pattern.
That is genuinely powerful. I can see how you could use that for all sorts of log parsing or data extraction. Absolutely.
Yeah.
But a word of caution.
Yeah.
It's really important to test your regular expressions carefully. It's easy to write a pattern that's too broad and matches things you didn't intend, or too narrow and misses things you need.
Right. So test, test, test. Maybe use one of those online regex tester tools.
Those are excellent for experimenting and refining your patterns before putting them in your script. Regex is a skill that definitely improves with practice.
Okay, so to wrap up regex.importRe, use functions like re.findall, combine character type symbols with quantifiers plus ANNMM to build patterns that let you search for and extract very specific information from text. Super useful for security analysis.
Exactly right. Those 3 areas, strings, lists, and regular expressions, they really form a solid foundation for using Python effectively in cybersecurity tasks.
Well, there you have it. We've done a pretty deep dive into these fundamental Python skills, working with strings, managing lists, and leveraging regular expressions. Hopefully you, our listener, have a clearer picture now of how these aren't just abstract concepts, but really practical tools.
Essential tools, really, for any cybersecurity pro who needs to analyze data efficiently.
They really unlock that ability to programmatically sift through all the text-based data we encounter in security, right?
Absolutely. It gives you huge gains in efficiency
Yeah.
and helps you find insights you might just miss doing things manually.
Okay, great stuff. And on that note, here's a final thought for you to chew on. Now that you've seen how Python can dissect and analyze security data like logs, usernames, and IDs, what other kinds of information, what other data types within the cybersecurity world do you think these techniques, string manipulation, list management, pattern matching with rejects, could be applied to?
Yeah, where else could these tools give you an edge?
Think about the different data you might encounter. Where could Python give you a powerful advantage? Definitely something to consider. Until our next deep dive, keep exploring.